Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now for Course 1 Honors for Tuesday, May 19th, 2020. All right, so in this Do Now, surprise, surprise, we're going to be doing another example of graphing an exponential function. So what I want you to do is take a look at this. We have this function h of x equals negative 8 times 1/2 to the power of x plus 2. What I want you to do is I need you to generate a table for me. I need you to use that table to make a graph. And then I need you to give me the domain, range, increasing, decreasing, horizontal asymptote, and end behavior. Okay, so please take a moment, pause the video, get me the table, the graph, and analysis. Then when you're ready, unpause, and you can see what I got. Okay, so remember, where it all comes down to this idea of making a table. No matter what function you are confronted with in high school, college, beyond, making a table is a great way to start to understand it, especially when there's only one variable, like just x in this case. So I'm going to start by plugging in 0. I like to have 0 in my exponent. So if I do 1/2 to the power of 0, I get 1, because anything to the power of 0 is 1. Then I do negative 8 times 1 is negative 8. And then negative 8 plus 2 is negative 6. One, two, three, four, five, six. Okay. Now I'm going to start by plugging in 1. Remember, we have a sense of a horizontal asymptote here. Also, while I'm there, I'll note that this negative 8 means we're going to be below 8. So we're going to be below HA, below the asymptote, because we have a negative. We're going to be approaching the horizontal asymptote because it's a number between 0 and 1, and this is going to be a sign of what our asymptote will be. So just that's some stuff to look out for. If you know what you're looking for, it helps you, right? It's helpful. So 1/2 to the 1 is a half, because anything to the power of 1 is itself. Negative 8 times a half is negative 4. Negative 4 plus 2 is negative 2. Now I'm going to plug in 2. Okay, a half squared is a half times a half. That's a quarter. A quarter times negative 8 is negative 2. Negative 2 plus 2 is 0. Nice. So this is amazing. We actually have a really nice x-intercepts. You don't always get those, so it's really nice when you actually have them. All right, let's plug in 3. So we have a half to the power of 3 is a half times a half times a half, which is an eighth. Negative 8 times an eighth is negative 1. Negative 1 plus 2 is positive 1. And now let's plug in 4. So a half to the power of 4 is 1/16. Negative 8 over 1 times a 16th, right? That's negative 8 over 16. That's negative a half. Negative a half plus 2 is 1.5. So here we go. See? First I shoot up by 4. Wow. Then I go up by only 2. Okay? So here's the sign that you've got an asymptote. When you see the change starting to ramp up, and then you see it starting to go down, right? So all of a sudden I go up by 4. Then I'm only going up by 2. Then I'm only going up by 1. Then I'm only going up by a half. You can slowly see that the amount I'm going up by is starting to level off, right? That's a sign that you're approaching the asymptote. So looking for patterns is really helpful. And so when you're able to make a table, the advantage of that is that you have all of the data in front of you, so you can start to recognize those patterns easier. So that's why you got to trust me when I tell you, when I preach the power of table making. Now I'm going to do 5. So a half to the 5th is 1/32. So I have negative 8 over 32, which is equal to negative 1/4. So that would be 1 3/4. So right, first I go up by 4. Then I go up by 2. Look at this. Ooh, then I go up by 1. Then I go up by a half. Then I go up by a quarter. What do you think I'm going to go up by next? Think about it. Look at this pattern here. Next, I should be going up by an eighth. Let's see if that happens. I just want to see. So sixth, we get negative 8 over 64, which is negative 1/8. Okay, so this is 1 point. So we get 1 and 7/8. So 1.875. Nice. So see, we want to find 8. So there's these really beautiful patterns with all these different kinds of graphs. But if you don't take the time to stop and smell the roses, i.e., to create a table, then you miss out on so much of the beauty of math. Okay, and if you really take a second to appreciate it, you can see it's a lot of really, really cool stuff. And you might say, listen, Mr. Murray, I'm not going to use this ever in my life, but using patterns and hunting for these kinds of ways that things change over time, and using those ideas to make predictions and to draw conclusions, you're going to do that about stuff even if it's not math. So this is really important stuff to work with here. So let's go ahead and plot these points. I've got 0, -6. I've got 1, -2. I've got 2, 0, 3, 1, 4, 1.5, and so you can see it starting to level out. Okay. Now on the other end, if I plug in -1, what you would get is the -1/2 would flip to a 2. You'd get 8 times 2 is -16, plus 2 is -14. So I'm going to try to approximate where that would be. Now I'm just going to come up and do the best I can to draw this graph. I would probably have slightly higher expectations for you if you were using a pen and paper, because it's a little bit easier to graph on pen and paper when you have this many points. Don't connect them with a ruler or anything. Please make it a nice curved line. These are supposed to be curves. It's not a line graph or anything like that. It is a curve. Okay. So again, things we want to note, again, as predicted, the -8 is telling us, that we're below the asymptote. Here's the asymptote right here. So the -8 is showing us again that we're right to be thinking that we're below the asymptote. The 1/2, again, showing us that we're approaching rather than going away from the asymptote. And the +2 giving a sense that value of the y value at that asymptote is 2. Now remember, the reason this is because when you are doing -8 to the 1/2 x, that number is either getting really, 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 really large. So when x is getting negative, what's happening is that 1/2 to the x is getting really large, because when x is negative, that 1/2 flips and becomes a whole number. So it becomes 2. So like for -1, it's 2 to the 1. For -2, it's 2 to the 2nd. For -3, it's 2 to the 3rd. For -4, and so on. So when x is a negative number, right, when you're taking that really, really huge number and multiplying by -8, you're getting a really big negative number. And by comparison, 2 has no value, right? So if you think about it, when we're at -3, this is going to be at -64. What's 2 compared to 64, right? When this is -10, right, 2 to the 10 is 1024. Okay? So if you think about it like that, if you're plugging in -10, you're getting -8192. And 2, when you add 2, you get 8194. But the reality is this: the number 2 makes up less than 1/10 of a percent. It makes up 2/100ths of 1% of the value of the function at that point, meaning the 2 has basically no value to the output at all when x is a big negative number. And that's reflected by the fact that x is shooting way down. But when x is a very big positive number, you're dividing -8 over and over and over and over again, and that number is becoming very, very small, almost 0. And so in that case, 2 makes up almost the entire value of the function. Let me give you an example. If it was +10, then it would be -8 over 1024. And what that is -0.007. So when you add the 2, when x is equal to 10, you get 1.99. So the 2 makes up almost the entire value of that function when x is big enough. And so what that means is that as x gets bigger and bigger, the value of the function is becoming equal to whatever this is, because whatever, what's happening is this is essentially dwindling away to nothing. So all that's left is the remaining constant. Now, when there's no number there, it's 0. So that means that there's nothing left, or 0. Okay, and then when there's a number, it will change depending on what that number is. Okay, so now we know this is going to be our horizontal asymptote. So let's take a look. The domain, again, is negative infinity to infinity. The range, so the arrow pointing down tells me I need to start with negative infinity. And then we know that it levels off at 2, never actually reaching it, but getting very, very close to it. Okay, here we're increasing from negative infinity to infinity, and we're decreasing nowhere. The asymptote is y equals 2, and here's the end behavior. As x goes to negative infinity, f of x goes to infinity. As x goes to positive infinity, let me just scroll down a little bit. As x goes to positive infinity, f of x is approaching 2. So again, pointing out some patterns. Notice 2 is the asymptote. Appears in the equation for the asymptote, appears in the end behavior, appears in the range. So again, think about these patterns. I know that I continue to chip away at these, but the reason I'm doing that is because I'm trying to help you identify these commonalities across every single thing you work with. Because sometimes, I think reasonably so, we're tempted to look at these and be like, okay, but what can I take out of this that's going to help me from the next problem? And that is what I'm trying to show you. These things about every type of exponential function that you can take with you for when you're doing the next one. All right, so thank you so much. Hopefully you're able to get this right. If so, congratulations. If not, please make sure you try to get an understanding of where you might be going kind of awry. Remember that I'm available every Tuesday at 10 a.m. And also, feel free to reach out to me if you want to arrange another time to meet. I'm looking forward to our hangout this week. Best of luck. I'll see you next time. And remember, you can do it.